So here's a plot of a utility function. As you can see, for lower amounts of consumption, this is the slope, this is the rate at which utility increases with consumption, and as consumption increases, the slope falls. So the first derivative decreases as consumption increases, or you would say that the second derivative is negative. Now, consumers act to maximize utility. So they try to have the maximum amount of consumption. That is the way individuals are modeled in modern economics. And if they have multiple period consumption, so if there's also a future, then they try to maximize their expected utility, where they should put some weight on current consumption, which they know, and they have an expected future consumption, because the future is unknown, but they have some information about the future. So they can have a expected consumption for the future. And of course, all this is subject to a budget constraint. That's the unfortunate thing, that you can't consume as much as you wish. There has to be a certain amount of money that you can spend. So consumers are maximizing utility subject to their budget constraints. So with this budget that they have, the consumers purchase a basket of consumption goods, which means that they don't purchase only one good, but they purchase different goods. Now within the basket, some goods may be substitutes for others, and the consumers will adjust their purchase to get the maximum utility. So the development of these marginalist ideas happened with economists like Cournot, Walras, etc. in the 19th century. So how does marginal analysis work? Well, the consumer equates marginal gains to costs. For example, suppose that the utility gains are given by Fx and the cost to the consumer is given by Gx. Then the net to the consumer would be Fx minus Gx, and at which point is this maximized? So that is beginning calculus. A function Fx minus Gx is maximized at the point where f dash x minus g dash x equal to 0. If the derivative is 0, then it's either a maxima or a minima, and for us it will be a maxima. So the consumer is going to have f dash x equal to g dash x, which is marginal analysis. So you look at what is happening at the margin by the consumer's consumption decisions, rather than looking at the, let's say, the average, for example. So there is this diamond water paradox. The paradox says that water is of much more use to you, but diamonds are much more valuable. So why does that happen? Well, if you look at marginal analysis, it will say, yeah, water is indeed something that provides you much greater utility, but because of its abundance, it can have a low marginal utility. So an additional unit of water to you is not going to raise your utility much, even though the total utility provided to you by water could be very high. But there's so much of it that you consume enough that you don't really care much for that additional unit, and you pay a small price for it. Well, unless it comes in a bottle, and I grew up drinking tap water. Now, here's an example of marginalist analysis. So I started with a budget and I have a certain utility function, and according to the prices that I see in the market, I choose a consumption basket. Now, after I've chosen the consumption basket, suppose my utilities from consuming the different goods in the basket are such that I'm willing to forego an apple in exchange of 2 peaches. So for me, at the margin, not the average, mind you, But at the margin, 1 apple equals 2 peaches. It does not say that the number of apples I have in my basket are half the number of peaches I have. No, that is not true. What is true is that for me, if I got an extra apple, I would be willing to give up 2 peaches. Now, what does that mean? That means that the market prices must be that 1 apple costs the same as 2 peaches. So the ratio of market prices is also the ratio of marginal utilities for me. So I adjust my consumption basket to the point where the utility I get from 1 apple equals 2 peaches, and I'm willing to give up 1 apple for 2 peaches. Or alternately, I'm willing to give up 2 peaches for 1 apple. Now suppose the price of peaches fall. What happens? Well, how do I respond? Well, maybe I can now get 3 peaches for 1 apple. And that's what I would do. I would start reducing the consumption of apples in my consumption basket and substitute peaches for apples. Now the fall in the consumption of apples assumes that there is no income effect. Or if there is an income effect, it is smaller than the substitution effect. Now the income effect basically says that if the price of peaches falls, then if peaches are, let's say, a substantial portion of my consumption basket, then I may perceive that my income has increased and therefore purchase more apples also. So if you're familiar with calculus, what we are doing simply is that we are finding the maximum of a function u which is dependent on goods like x, y, etc. And at the maximum, the partial derivative of u with respect to x will equal the partial derivative of u with respect to y multiplied by dy by dx. So this simply is that at the maximum, the rate at which the utility changes with respect to x would equal the rate at which it changes with respect to y multiplied by dy by dx. Now, dy by dx is obtained from the budget constraint. So dy by dx is essentially the ratio at which we can substitute, let's say, peaches for apples. And these two are the partial derivatives of utility with respect to peaches and apples. So we define marginal utility as MUI. So that's the marginal utility with respect to good I. And for good X, it will be MUX, which is del U by del X. So that is the rate of change of U with X, or the increase in U for 1 unit increase in X, if you take a linear approximation. So for Y, the marginal utility is MUY, and that is equal to del U by del Y. So what we are getting is that from the previous slide, I said that the dy by dx comes from the budget constraint, and the budget constraint is going to tell you that dy by dx equal to the price of x divided by the price of y. Why is that so? Well, because your purchase of apples or peaches is not going to change the market price of apples or peaches. So the price for you is fixed for apples and peaches. So the amount of apple that you can exchange for peaches depends on the relative price of apples and peaches. It is actually equal to this ratio. So this is the number of peaches you can exchange for apples, and that is inversely proportional to the price of peaches. So if the price of peaches is higher, you can exchange less peaches for a given amount of apples, or if the price of apples is higher, then you can exchange more peaches for a given amount of apples. So going back to the previous slide and substituting dy by dx equal to px divided by py and putting in mux and muy in place of del u by del x and del u by del y, what we get is this equation that at maximum u, so at the utility that you have when you've organized your consumption to get the maximum possible utility for your budget, for the amount of money that you have to spend, we are going to have marginal utility of x divided by price of x equals marginal utility of y divided by the price of y. Now, if you're not comfortable with calculus, you don't need to know how I got here. But you should get the intuition for this. The intuition for this is that at the optimal utility, which is what you're going to choose given the amount of money that you have to spend, the utility that you get from consuming one more unit of apples divided by the price of apples will equal the utility that you get from consuming one more unit of peaches divided by the price of peaches. So if the utility that you get from consuming one apple equals the utility that you get from consuming two peaches, then it must be that the price of apples is double the price of peaches. So for one apple, the price must be twice the price of a peach. Now, consumption decisions for consumers extend over multiple periods. So it is not only choosing the amount of various different goods to consume in one period, they also have to make savings decisions. That is, how much are they going to save today for future periods? So saving is transferring consumption from the present to the future. So they have to make a decision how much consumption to transfer. Now, savings decisions are based on consumers' expectations about the future. So they do not have perfect knowledge of the future, but whatever knowledge they have, they make decisions the best they can given that knowledge.